There is this concept where we can achieve immortality by uploading our mind to a computer. As an engineer, I'm interested in the technology that's involved. And while putting this video together, I talked to many experts working in the field. And what I've learned through these conversations is just mind-blowing. It appears that recent advances in the scanning technology, as well as in artificial intelligence, making the possibility of mind uploading more and more real day by day. Let's break down the problem of mind uploading. At first, we have to scan the brain at a very high resolution in order to obtain the images of the cross-sections of the brain. And then, based on these images, build a digital model. This model will run on a powerful supercomputer, where a digital version of me will continue to live on happily ever after. This is what we call mind uploading. And it can get really confusing here, because it sounds like we have to create a high bandwidth connection of the brains to the machines, similar to what Neuralink is working on. But in reality, it's about building a digital model of the brain that's somehow equivalent to the actual physical brain. I'm personally excited about this technology because it can eventually free us up from the limitations of our physical body, which will not just allow us to live indefinitely, but also to invent, to engineer things without any limitation of time.
Of course, mind uploading is also a way that people think of to get towards what's called substrate independence, and therefore a longer lifespan. And then going beyond that, this is really the question for humanity as such, is the ability to grow beyond our current limitations, beyond the place that we evolved into, to, for example, live in spaces where humanity didn't evolve to be in, such as in space or in virtual reality or on other planets.
I think there are some obvious advantages to being digital as opposed to biological. They might not appeal to everyone, but just if one looks at some basic functionalities of the digital substrate, first you have the easy ability to make backup copies. Just as with any other software, you can just store it to file. That's hard to do with a biological brain. So we are kind of, as biological creatures, subject to accidents, and even if you could stop aging, would eventually you get run over by a bus or something. Whereas if you had a backup copy stored, every day or something, at most you would lose 24 hours.
The first problem is actually scanning the brain. And here we're interested in both structural and functional aspects of it. We have to perform a very detailed scan that captures all the neurons and the connections between them, and ideally the momentum as well, which pulse is sent at which frequency. And I was surprised to learn that out of all technologies involved in mind uploading, the scanning technology at the moment is the most advanced. We've already scanned 4 cubic millimeters of the mouse brain and the whole fruit fly brain. Now, there are actually several methods to do this. One of these involves using fMRI scanning, basically using a strong magnetic field to create detailed images of your brain while it's still working. fMRI technology is quite useful for the medical applications, but not so useful for the mind uploading. And the reason for this is simply the resolution.
You can't see much. The smallest voxel size on an fMRI that has a Tesla level that's not too high to survive is so rough. It's so big that you're really only capturing very global activity in the brain.
In contrast to fMRI, the usage of electron microscopy is the standard nowadays. It's basically done using a very powerful microscope that uses electrons instead of light to produce a magnified image of the brain structure. Just this year, scientists scan a whole mouse brain in the most detailed fashion. And this was a big breakthrough. To summarize, we're already getting pretty good at collecting the necessary data. The main challenge is interpreting this data and then building a digital model based on it. Clearly, this will still take quite some time. That's the reason why the startup Knaapen is working on the technology to preserve human brains. The idea is to preserve it for the future. So whenever the mind uploading technology arrives, we can scan and upload it. To preserve the brain, Knaapen has developed a chemical solution which can be injected in the body and preserve the brain by turning it into a glass. But this would have to be done while a person is still alive. This could work, for example, for ill patients who decided to take part in this project. This idea obviously generated quite some controversy.
Nectome, of course, is interesting because they at least care about how to prepare a sample and how to prepare a brain so that it can be stored for a period of time and get to that time when these technologies are really ready. So that's an essential company for that main reason.
Anyway, Knaapen technology is for sure relevant for the mind uploading, but it's not the mind uploading itself.
But the companies that do exist that actually work on it, so very, very fresh, very young, is our own company, Next Up Neuro. We want to solve the problem of going from data to a model. And we also want to be able to validate that this model is actually what we were looking for. And Neuralink is working on neural implants, so on BCI, which is great, especially for today's medical need, but it's also not directly related to the problem of whole brain emulation because it's not obvious. You know, if you have a brain-computer interface, you just connect neurons in your brain, probably not all the neurons, but some neurons in your brain, with a computer so they can talk to each other. How does that make your mind exist in that other machine or somewhere else? That's not clear at all. You know, we've had lots of kinds of BCI already where that's definitely not what happens.
From the discussion with Randal and various research papers which I read, it seems that obtaining the data is not the problem. The problem is building the digital model from this data and then validating the model, that this model is actually doing the same thing as the actual physical brain. What's interesting, when I was working on this video and researching companies working on this technology, I was not able to find many. And that's because it's still mostly the research which is happening across various labs and universities. And in general, the term mind uploading is not used in academia because it sounds like science fiction. And that's why there are not many companies working on this just yet, because companies don't prefer to jump into the research, but jump into the market-ready technology instead.
The places where most of this is going on is not companies. It's because this is very much still research. It's labs. I think you really should look at, for example, the laboratory of Theodore Berger and Dong Song. They have 2 labs at USC, University of Southern California. Then there's also a group led by Professor Aurel Lazar from Columbia. He runs the FlyBrain lab. And he has a lot of experience in this area, so-called system identification. System identification is actually what we're just talking about, but it comes from electrical engineering, from, for example, analyzing electric circuits or chips and trying to reverse engineer them. And he's applying this in neuroscience.
The whole flow of mind uploading looks rather complicated right now. So that's why I was thinking, what if there is a completely different way to do that? What if there is a shortcut? What if, even without complete understanding of the brain, a neural network can learn to emulate it? Meaning that it might derive the function based on all the outputs. And that's exactly how neural networks learn anything. They basically observe a lot of output data, which is coming, let's say, from a black box. And then they will reverse engineer the function itself based on this output data.
It is conceivable that even without looking inside the brain, but just looking at the output traces of, say, a human, that the text they have produced, maybe video feed and recordings, if you had enough of that, like a couple of decades of like, if you imagine you recorded everything a particular individual did, and then you had a super intelligence looking at all that information and trying to infer from that what would the brain have been like that would produce this data set. It seems conceivable that you might get quite close.
But what if we can use it for the mind uploading to solve the biggest bottleneck, the modeling problem?
So, for instance, there is another group that is trying to create a company, just like we created Next Up Neuro, who specifically care mostly about using LLMs, large language models, and similar machine learning tools to try to work on whole brain emulation. And that's not wrong. I think that's a great path to take, because LLMs and other machine learning tools definitely have a very important role to play in making neuroscience more systematic, faster, and better.
When we eventually come to a digital model, maybe with the help of AI, the next huge problem would be to validate this model. Let's say a neural network has correlated a certain structure in a brain to some function, but a neuroscientist is not certain what exactly its function is. It's just some type of a neural activity. So, and this is the biggest problem. How do you validate something which you can't understand?
So in any case, just getting back to why this is a problem, or not a problem, why you just need to be aware of what you can use it for and what not in whole brain emulation, is that these LLMs, or generative transformer models, are very useful in filling in missing data where they know what to do. So they can, for example, if you do an electron microscope scan and there's a part where there was noise or something went wrong with the tissue, it can help fill that in with what was probably there. And that's quite useful. But it gets a little risky if you rely on the LLM to make interpretations or to generate inferred output for the whole of an individual brain. And that's because the LLM will have a tendency to erase individually unique characteristics of the data, which of course is what you actually want. You want to have an emulation of that individual human brain, not of a general human brain or a likely human brain. You want that specific, unique human brain. And then if you do what they call adding some temperature to make this LLM more creative, then it has a tendency to confabulate, to make up things that are satisfying to the user, or the scientist in this case, without actually being testably correct.
Mind uploading possesses a massive technological challenge. But let's say we've figured it out and we managed to replicate my brain, one-to-one digitally. The next question is, will it be conscious or not? If we replicated all the cognitive capabilities of my brain in there, it's hard to say why consciousness would not emerge. What is so special about it? And that's really hard to answer because in reality, we don't really know what consciousness is.
Well, I think I'm a computationalist, meaning I think in principle, conscious experiences can be implemented by a wide range of different substrates. It doesn't have to be hydrocarbon chemistry. It could easily be silicon substrate, and that what makes something conscious when it is conscious is the kind of structure of the computation that is being performed. You have to have not just a structure, but you have to actually run the structure, like run the computation. So just having a file of like a scan of a brain stored on a hard drive somewhere, like wouldn't be continuously having conscious experiences, long as it's just sitting there.
Just think about it. If the same computation is implemented on a computer, which is twice as fast as me, I could have more mental experiences in the same 24 hours, or I can produce more results, or I could have more fun. And this sounds appealing.
On one hand, could be a path towards advanced forms of machine intelligence. I mean, basically you have two paths. You could either do artificial machine intelligence, where we create sort of synthetic programs and learning algorithms, or you could just try to copy and paste from biology. If you could transfer a human mind into a computer, then if you then run that mind on a faster computer, or if you make a lot of copies, you could potentially have a powerful form of machine intelligence. Now, it does look, in the world we're actually in, we'll probably get to machine superintelligence first through the artificial path, given the remarkable breakthroughs we've seen in ADI in recent years. And then I think this machine superintelligence will maybe develop the technology to enable mind uploading.
It's clear, once mind uploading is here, it will be huge. It will change the society forever, and hopefully will have a lot of positive outcomes. But let's think for a moment. What happens if it goes all wrong, or this technology is being misused? Because we know that there is not a single technology which cannot be misused.
So the question really is, if you're thinking about ways it could go wrong, just like with other technology, say, for example, someone discovers splitting the atom. How can it go wrong? There are many different ways that can go wrong. So whole brain emulation, mind uploading could also be misused. If it is not set up in the right way, if there isn't regulation, if there isn't oversight, if there are no security measures put in place, then you're going to see people abusing it one way or another, whether it's to play advertising in your mind or read your mind and use the things in your mind for their benefit or whatever, or clone you, copy you for when you don't want to be copied.
Another, which I also actually described in my book Superintelligence, which is now almost 10 years old. There's a chapter there about a world where machine intelligence is produced through mind uploading, and you then have a big population of uploaded minds that are competing in an economy and competing to make more uploaded minds, and where, in order to actually succeed in this competitive environment, they need to streamline and optimize their minds. So it turns out that for many jobs, maybe you don't need certain parts of the brain, and so you would then have competitive pressures to sort of extirpate and remove all superfluous elements that maybe are valuable from the perspective of what we want and care about, but that might just cause you not to be competitive in this kind of hyper economy of uploads.
So just like with artificial intelligence, we would need regulations. Let's say, what will be the social status of this mind, and whom the rights to this mind will belong to? Let me know your thoughts in the comments. I think at the current pace of development, it might take us another half a century. But this does not mean that we don't have to prepare already now in terms of legislation and understanding the social impact.
If you look at it in terms of the time spans that have become commonplace in Silicon Valley, then it's still very much in the research stage. And so consequently, it's very far away. Something I sometimes say is that I'd be very thrilled to see it in 20 years, but I would be surprised and disappointed if humanity couldn't achieve it by the end of the century.
And of course, the advances in artificial intelligence are expected to speed up the pace of the current technological development.
I think once you have, radical superintelligence, then you really get the kind of telescoping of the future, where all those developments that maybe we could have pulled off in the fullness, if we had 40,000 years to work on it, we would have probably perfect virtual reality and uploading and cure for aging and space settlements and whatnot, right? But all of that progress in 40,000 years might then happen on digital timescales, in 4 months or 4 years, once you have a superintelligence doing the technology work.
Another very interesting point here. Once mind uploading is successful, it will help us to gain some clarity with respect to the simulation theory. As you've likely heard, there is this theory that we all live in a simulation, in a beautiful simulation, which may or may not be true. However, if we can make a mind upload and then run a simulation, this would increase the probability of simulation theory a lot. And this would be cool.
I think it would feed into the simulation argument by strengthening our reasons to accept the third possibility there, which is the simulation hypothesis, that we are ourselves currently in a computer simulation, because it would demonstrate that we had the technology for creating conscious digital people with experiences like ours. Like whole brain emulation would be one way of doing that. Then you would have the technological capability to do this. Then if you combine that with the assumption that there would be some civilizations that were actually interested in using the resources, to produce these simulated minds, then you kind of can check off another box, and then there's a little more footwork there, but basically you would increase the probability of the simulation hypothesis being true. The closer we get ourselves to being able to create, I call them ancestor simulations, the greater the probability that we are ourselves currently living in such a simulation.
Even if we can upload our mind, the question whether we should remains open. Let me know if you would like to be uploaded in the comments below, and they will reach out to you. Just joking. Stay curious. Ciao.